Hello everyone, today is my day 5 of C++ DSA journey. In today's live stream we will be again solving some array problems on LeetCode. We will try to solve them together and I will explain my thought process. If I get stuck in a problem, we will try to get hint of that. If after that, even after that, we will not be able to solve it, we will try to work through it together. So let's start the video stream. Okay, so stream is live now. Let me check if my mic is on. Hello, hello, hello. Okay. So in today's stream, I have chose two problems. So the first problem will be remove duplicates from sorted array. And seeing this problem for the first time, I will try to solve it on live. 1 minute. 1 minute. This was not the first problem, I think. The first problem was move zeros. Yeah, the first problem was not this. It was 1 minute. Okay, so we will start from the remove duplicates first. Order doesn't matter, we should be able to solve the problem. Okay, so here given an integer array nums sorted in a non-decreasing order. Okay, like it is sorted in a decreasing order, like here also. Remove the duplicates in place such that each unique element appears only once. So we have to remove the duplicates in place such that only one unique element is left. Like here, we only want unique elements to be present in the array and remove the duplicates one. Then it will be like this. Output is equal to 2. So we have to remove the duplicates and the relative orders of the elements should be kept same. And we should not change the order of elements. Like here, the orders of elements are in increasing order. We can see. Consider the number of unique elements nums to be k. Removing duplicates, return the number of unique elements k. The first k elements of nums should contain numbers in sorted order. The remaining elements should be beyond index k-1 can be ignored. Okay. So if it is already sorted, I think we can first we will try to do it with the two pointer. Okay. So I will take t start equal to nums dot size and end is equal to nums dot size minus 1. Okay, so we have taken two pointers here. The first will be the start point, and the second one will be the end point. 1 minute. So teacher starts will be the size. It will start from the 0th index, but we have to start with the first index so that the end variable can compare the previous value with the new one. So what we will do, mm, we will we will be using the approach of yesterday's. We will be using the yesterday's stream approach here. That was that was okay. Integer start is equal to 1. Start is equal to 1. Integer end is equal to no man, this will not work like that. I have forgotten the thing that I have written to yesterday. Let me check for it. What was that? Well, 1 minute. Okay. So we have to create I is equal to 1 and j is equal to 0. So I will start from the 0th index and j will start from the 0th. I will start from the first index and j will be starting from the 0th index. That is 1. So at this we will check 1 minute. If nums, sorry, if nums I equal to nums of j, that's when nums of I equals to nums of j, I is equal to 1. Start from the first index to use index. Okay, so we are, yeah, 2 pointers will be used. This is the top here topics we can see. 2 pointers is also used in this, so we'll try and take a hint. Okay, if nums of I equal to nums of j, we have to this is true, if this is true, we have solved a problem like this yesterday. I think that was duplicate sum. Let's see what approach we tried there. Contains duplicate. Yeah, here you can see. Okay. First, second, third, fourth. Okay. This will also run off contains duplicate. Is gone here. So while j is less than nums dot size, because we have to run it till the last element. If nums of I j, what we have to do? We have to return in this we have written true, and I is increasing and j is also increasing. So that if it is not true, we will have to return false in this. Okay, let's see this question again. So in this, okay, I think we have to return false. That I plus plus and j is also plus plus. That if this is not true, if nums of I not equals to nums of j, we have to return true, so that unique elements get stored. We will run this, check if what's happening. Compile error. Undeclared. Okay. This is an integer. N is equal to 1, comma. Okay, this. First curly brace, second, third curly brace is there. First, second, third. I think there is an extra curly brace. Okay. So case 1 and case 2 answers are wrong. Let's see what output it has given. Output is empty. Okay. So I think we have to create empty vector also and return the value in that. So what we will do, we will create an empty vector. Vector integer, storing integer values, named we will name this rm duplicate. Okay. It's true. Rm duplicate. Okay, push dot back. What was the syntax for that? The syntax was, let's check the syntax for that. I forgot it. Okay, we have used that and missing number. No, it's not missing number. What is an intersection of two arrays? Yeah. What is used in intersection of two arrays? Result of spec. Okay. So we have to write this like rn dot duplicate dot push back. What is to push back? We have to push back. We can push back the nums I or nums j. Anyone. So we will push back nums of I here. Think it will work now. Let's see. It's working or not. Holy moly. It's not working. Output is 0 even after that. I think I have to return. We have to return else. Else. Maybe it will work now. Oh. Okay. Extra curly brace. Expected curly braces. Error non-void function does not return a value in our paths. Non-void function does not return value in our. What does that mean? Let's ask this and compile it. What's the error it's giving? This error means that my function's return type is not void. Like it's int. Okay. I will not ask it. I will ask. Don't give me the code. I'm solving it in live right now. My code has 2-3 logical issues. Okay. I have put return statements inside loops. So because of that, after the first comparison, the function will exit. So because of that, we will be unable to traverse the whole array, and duplicates will not be properly removed. We have to modify it in place and have to return the count of unique elements. Okay, which are the hints? So it is saying that extra vector is not required here. So I will remove this and this. We have to use return type according to integer. So I think we should, instead of writing true or false, we should return 0 and return num size, if it's true, for that let's take hint from him. We need to modify the array place, and the size of the final array would be potentially be smaller than the size of the input array. So we want to use a two-pointer approach here. One that would keep track of the current element in the original array, and another one for just the unique elements. Okay, so I think I have to take strong hints now. According to the problem, we have to calculate the count of unique elements, not boolean. Oh yeah. I have used return here, and anything after return not executes. Forgot it. I think mm, let's ask here. Let's see. Perfect. Uh, my mistakes are return time mismatch. We have to. I have to count unique. I have to return unique numbers count, unique elements count. I have return inside loop means function exits early and it not traverse the whole array. Nums. This is the we have to go like this. Okay. Here is an variable created int I that is unique stored unique index. Okay, and we've created a for loop here. DSA that starts from the first in from the first index. J is less than number of elements. Okay, in the array. J plus plus. If nums j not equal to nums I. Okay, so I think it is just written like this, but the logic is same here because in this I was also comparing if nums of I is equal to nums of j means the value after is equal to value before or not. So the logic is same, but I think we will have to write the code like this. But words, okay. If the vector is empty, it will return 0. Okay. And if it mm, nums of j is not equal to nums of I, if the element before is not equal to element after, it will what it will do it will increase the I index, that is unique index, and after that it will check that if nums of I equal to nums of j. Okay, and here it has written I plus 1 count of unique elements. Whenever nums j is not equal to nums of I, it will return I plus 1, means the count of unique elements will increase. Okay, let's see. So what we have to write? We have to write if first we will remove this one. So if what was that? If just okay. If nums is empty, we have to return 0. We will create an integer I that is equal to what? Nums I will be equal to 1. Think it was 1. It was 0 because it will count the unique index. Unique index. Okay. Now we'll use the for loop here. J is equal to 1. J is less than nums dot size. J will increment operator I will use. Inside this, we will check if nums of j not equal to nums of I. Okay, for that inside this, what we will do these are what we are doing here. We are doing I plus plus and check if nums of I equals to no nums of j. Let's see the running example before writing that code there. If there is an example given, if there are 5 elements arrange like this in this order in an array. 1 has occurred 2 times and 2 has occurred 2 times twice and 3 has occurred only 1 time. So we start I from 0. So nums 0 is equal to 1. Okay. Nums 0 is equal to 1. Okay. Sorry. Nums 0th index is equal to 1. Yeah. See, 0th index is 1. When j will be 1, nums 1 is equal to 1. Duplicate. So it will skip. Further, what is the code written side down or what it's doing? Explain me. Okay. J is checking every element of the array. I is the unique position pointer. It tracks where was the last unique element placed. Condition check. If nums is not equal to nums I, that means we have got a unique element. After getting that, we will increase the unique position by 1. Okay. And we will override it and the new uh, positioned element will be the new element. Okay. Will be the new unique element. Because of that, stores it will store the unique elements in sequentially. Try an example. Okay, start is equal to puts will was the same example as before. If j is 1, nums is 1, skip these 2 nums 2. Okay. In end we will get I is equal to 2 and return I plus 1 is equal to 3. Unique elements is 1, 2 and 3. Explain me the whole code. 1 minute. Explain the code in English so that the viewers can also watch what is writing. Alright. So step 1 is this. If the array is empty, return 0 immediately. Okay. Start with a pointer I at position 0. This pointer marks the last unique element position. Okay. Step 3 is that traverse the array with another pointer j, that is traversing the array from the first index to the last index. And inside this, what we are doing, we are comparing current element with the last unique element. If it's different, that means we found a unique element. And we will move the unique pointer forward and override that position with the new unique element. Okay. And in the step 5, what we have done at the end, I plus 1 is the count of unique elements. What does that mean? What? Further, how? getting stored when it's not equal to y. When we have moved the pointer forward and overwrited the position of previous unique element with the new one. Good question. How it gets stored? See, you have to contrast I marks the position of the last unique element. J scans through the array. Okay. When you find a new element, nums j is not equal to nums I, you move I forward. Okay. This means okay, I found another unique element. So the next slot in the front portion of the array should hold it. You override that slot. The copies. This copies the unique element into the next position right after the previous. Okay. So basically, the array's front section is being rebuilt with only unique values. Every time you find a new value, you push it into the next slot. Starting the index from 0th index, first element is 1 is unique by default here. So j1 equals to it will duplicate skip to not equals unique elements will move from unique element will be now I is equal to 1, that is 2. But how? If j is 2, 0, 1, 2, nums2 is not equals to nums0 new unique 1, 2, 2. Tell me in simple language. I think I'm tripping a little. Let me explain the whole. If there is no elements because there are numbers, so let's say pointer I starts at 0. Think of I as the box where the last unique element number is stored. Okay. So there is a scanner that checks each number one by one. If num stays the same as num side, it means duplicates. If num is different, it means new element. Move I forward and put this new number at that position. Okay. First unique element is always at index 0. First unique element, yeah. When you find a new unique, you shift I forward and copy that number there. Return count at the end. I plus 1 tells how many unique numbers are stored in the front part of the array. That's the answer. And means we will get the output as 3. And then yeah, because the last unique element is at position second, is at second index. So the function returns I plus 1, that is 3. That means 3. That 3 means there are 3 unique elements in the array. Okay. So if not equals this I will increase plus and nums of what is that? Okay, nums of I will be equal to nums of j now. Nums of I equal to no nums of I check if it's equal to nums of j or not. Yeah, we have already moved the unit and after that we have overridden position with the new element, unique element. Like when when I is equal to I is at 0th index. So this actually if it's not equal to I, if it's equal to I, it will skip. See, if it's not equal to, so it will skip and the pointer will move forward and the new I will become 1. Okay, and j will now move forward to index number 2. Yeah, see here, j is equal to 2 and check that if 2 is equal to 1, but it's not equal to 1. 2 is not equal to 1, so it will return 2 is not equal to 1. So it means we have found a unique element. So we will move the pointer forward and I will now become this second index and j will become the third index, and we'll again check for that. See, it's checking again for that. So it's duplicate and skips that. For that j becomes 4 and j becomes the 4 index and I becomes the third index, that is 2. So again just compare and in the result it founds the unique element, and then I is equal to 2 and we will return I plus 1, that is 3. Unique elements are 1, 2 and 3. I is the index of the last unique element we stored in the front part of the array. Let's start from 0. So if the last unique element is just 2, that means there are actually 3 unique elements. Okay, that's why we convert the index count into a count. Example, and after the unique element 7 to 3, last unique element is at z. So I is equal to 3. So function not returning the value stored in them, it is returning the number of unique elements. Okay, here the number of unique elements will be the okay. I am understanding it a little bit. After removing the duplicates, we are left with this. So the indexes of it will be 0, 1 and 2. But there are 3 elements, we have to return the count of that. So for that we have written, we have wrote this statement that return I plus 1. So that it tells the count of that. If there were to be suppose 4 elements. After removing all duplicates, the number of elements present inside was to be equal to 4, but according to index it is 0, 1, 2, and 3, and we have to print the count of unique elements. So for that we do I plus 1. So in the result we will get 4. Okay. Return I plus 1. Output is 1 and 1. Expected is 1 and 2. I think I've done a mistake here. Let's check. Is there any mistake here? Small mistake. Okay, okay. Oh, I mistakenly wrote the compare operator. But we are not comparing, we are giving no value to y. That is the current j. Okay, so now the test cases are set now. Let's add our test cases. Case 3 is 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 6. Okay. Okay. 0, 2, 2, 4, 4. Sorry. 0, 2, 2, 4, 4, 5, 5, 5. Okay. So my test case is also passed. I think the time complexity of this will be equal to n log n. Let's see. Beats 100%. Okay. Can get fun analysis for free. Two pointers. Okay, big of n. Okay, because we haven't used any n log complexity here. I think. Okay. We have achieved the optimal solution perfectly. So what's happening here? I think it's for traversal of whole array. is unique. I plus plus signing value. I think that. Yeah. Move the unique pointer forward. Okay. Override that position. A new element. It returns count of elements left after removing duplicates in the sorted array. I just find the index count right when num is not equal to num psi. Yes, Pradhay, let me clear it in English. English is storing the index of the last unique element here. Every time we found a new unique move I forward, I just input that new number at num psi. So at the end, I is pointing to the position of the last. Okay, okay. In the end, I will be pointing at the this position, that is 2, and we are returning that position in the end and plus 1, so that it tells us the count of elements present, count of elements left after removing all the duplicates in the array. So this was the first problem we solved today. Woo! Now we will check if, okay, my acceptance rate is also increased. Let's add some problems to my favorite list. So this was the problem I solved before. Okay, single number maximum salary problem. Let's save it also. Contains duplicate. It was a good problem. We solved it using 3 approaches yesterday. It is already favorites section of two arrays. Let's add this also. This was the code for that. Missing number. We will try to solve this problem again today by using the same logic. This logic again without getting any hint or anything. We will try to write the whole code. I don't know why I'm loving bit manipulation things. The problems in which bit manipulation is used. I left those problems for now. Don't know what will happen in the future problems that we will be solving. Let's add this also. Favorite, add it to favorite. This is my profile. Okay, now let's go to the next problem. That problem is move zeros. This is a good problem. Okay. So I am doing live from the for 1 hour. I have done live for 1 hour. Let's see if it's working. Yeah, it's working. So here is the only problem we are going to solve. The problem number second. Given an integer array nums, here is given an array called named nums. What we have to do in this, we have to move all zeros to the end of it while maintaining the relative order of non-zero elements. Means we have to move all the zeros in the array to the last position and maintain the order of elements like this. In this we have to write the non-zero elements first. After that we have to move all the zeros to the end. Here's an example in this. Only zeros present, so the output will be zero because array is only holding one value, that is zero. So let's try to solve it. Why do we not returning anything in this question? No, that you must do in place without making. Okay, we have to do this in place without making a copy of the array. Please. Okay. Could you minimize the total number of operations done? Array into pointers. Okay. Let's see. So I think we will create an integer 5 0 and in case j is equal to 1. We take so I will start from the 0th index and j will start from the first index. And inside this, we will check if 1 minute. While j is less than nums dot size, we will check if nums of one minute. Two pointers. Okay, there we have to use two pointers. Approach here 0 1 0. We have to write a condition like this: if nums index is equal to 0, we have to store it in another. Okay, nums of I think there will use two for loops here. First for loop, check. Let's take a hint. Okay. In place means we should not be allocating any space for extra array. Okay. But we are allowed to modify the existing array. Try coming up with a solution that makes use of additional space for this problem as well. First apply the idea discussed using an additional array and its solution will pop up eventually. To have one pointer for iterating the array that just works on non-zero elements of that array. Okay. While it is less than nums dot size, then it will be not like this. There should be something like that. If it's 0, it will not get stored in the new array. If it's more than 0, it will get stored in the array. And in the last, all the non-zero, all the 0 will be stored in the, will be pushed back in the array. What we do here, we can try this solution. If we sort this array, okay. Let's take a hint from it. Don't even give me. Shift non-zero elements forward in order, then put zeros at the end. Do you want me to walk first step drag and pointers I just so you can realize how changes at each step now. I zero, okay. We'll traverse the whole array with an inner pointer like j, like here. I zero and we are traversing the whole array using the pointer j. Okay. Fill the remaining position. Okay, let's see. Or teacher I, no, teacher j. Or j is equal to 1. J is less than num or size. J plus plus if nums of oh mm, Gnet paste the non-zero element at the correct position. That will rewrite of the problem. We will use I to mark the position where the next non-zero should go. J is equal to 0, 0. Skip. That numbers. Okay, 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 okay. Yeah, yeah. If nums J. What? Nums J is more than 0. Okay, I'm almost catching the area, but there is a small mistake. Problems in your current code nums I equal to num J. This line is. Oh, okay, okay, I know. Not comparing. Non-zero. More than 0. Condition should be not equal to 0. Because the problem is not about greater than 0, it's about non-zero. It should be non-zero. Not equal to 0. It can be negative also, I think that's why we should write the problem like this. Think about that as case if any value is negative in the arrows, so that it will keep it also in the front. Yeah, they will automatically increase, so we do not have to write J++ here. Okay. Extra J will side will skip elements. Okay. I position when I J scans the array. Where the next non-zero should go. If num stays non-zero, put it at num side, then move I forward. If num stays not equal to 0, if one is first index is not equal to okay, if num j is not equal to 0, then num psi is equal to num j. Yeah, because it is non-zero. But I think j should start from the 0th index. Should j start from the 0th index? Yeah, yeah. I was thinking about this. If we start the j from 1, we will not be able to check if the first element is 0 or not. So I can remove it from here also and write it inside this teacher j. Let me run it. Getting okay. It's giving an error. Holy, the second case, it's passing the second test case. 1, 3, 12, 3, 12. Think there is a small mistake left to find. First we check it by ourselves. Okay, if nums j not equal to 0, nums I equals nums j I plus plus. As j is increasing, I is also increasing. But let's see what it does. One last step. You are using I to track where the next node. So for that part, what's missing after finishes the front of the array has one non-zero element in order, but the remaining slots from I to and string holding word values could be duplicates or leftovers. You need to fill those remaining slots with zeros. Example loop moves forward from front part is fixed. But notice last pointers are non. Yes, that's why after the loop you must set all positions from I2 and S0 final result. So the forget the second step, filling the rest of the array with zero after clearing. Okay. Just add one more loop or step at the end to set the remaining elements. Zero. Loop saying one more loop or step. I think that step should be else. Nums of j equals to 0. Nums of index of num will be equal to 0. And I plus plus compile error else. Why we got an error? Okay, second curly brace, third curly brace is here. First, second, fourth, one is also present. Okay, expected expression else nums say equal to 0. That You are very close now, but there's still few mistakes in this version. Else in C++, else cannot have a condition. Okay, yeah. If it was else if, we can put a condition, but it was else. Oh, okay, I got the word. Okay, logic mistake. You do need to handle the else case inside the loop. Why? Because the job of the loop is only to move non-zero elements forward. Okay. Zero should be handled after the loop by filling the remaining positions with zero. Missing, for instance, after the loop from index side till the end of the array, you could set all the video values to zero. Otherwise, leftover values will remain like duplicates. Correct process. Loop through the array j if num c is non-zero. Put it at num sign for after loop ends. Fill all positions from I to end with zero. Loops put non-zero in front, then fill this with zeros. So I have to use another loop. You say that sets all the index value to zero by default. First let's move forward. Okay. Now I could next step please sort. Second loop sets everything from index. First loop moves from zero forward. Okay. Now I is equal to 3 and next empty slot. C. We are using for each loop here now. Disconnected. Okay, OBS studio was disconnected. So we wrote the for each loop myself, in which it is traversing through the whole array and setting all the values on side nums to zero. Test past case second, but not the case first. Think I plus plus. What's the okay? 10000 1312. Let's ask it again. I will point out mistakes, spelling mistakes, wrong placement of second loop. You wrote the second loop for and text inside the first loop. That means it will run again and again for every j which is wrong. Okay. So that gives you the values, not the indexes. But here you need indexes I2 and set values to, so you should use normal for loop with an index. Okay. You nums I equal to 0 inside the range, but I is fixed at that point, so it will keep overwriting the same spot. You need to loop from I to num size at is position at 0. Okay. So saying that we should not use for this loop. We should use normal for loop. Teacher I is equal to 0. I is less than num dot size I plus plus. Okay. Correct sections. Either p is equal to y. Yeah. Can use k also because I is already initialized 0. Can use it here also. Nums k is equal to 0. So nums k, yeah, nums k. I think it will again give the wrong result, or maybe runtime error because it is nums I. I was thinking for runtime error sign integer overflow. Wrong loop type. It was wrong loop type, so we removed it. Second replacement. Okay. We have mistakenly. Oh yeah. Okay, because if you take k name here you are. Okay. Yes, of price extended one correct is the loop variable. So use the loop variable here. Compiler. Correct its nums index would be 0. Correct skeleton. I have not declared k. Yeah. K is equal to y. K is less k plus plus. What I have already done. I have already done it. Undeclared identifier. Mm. Declare case as int. Okay, integer. So type of integer. Data type is integer. Yeah, place the second loop inside first loop. Means for every j I am trying to fill zeros. Okay, but it's okay. Okay, not spots. So we used another for loop in which we started it from the first index and it could go on to the last index by increasing, and we set the value to default 0. But how does second loop is not interfering with the non-zero element values to 0 by default, right? Or the second loop doesn't fit non-zero. In the first loop, we already copied all the non-zero elements to the front of the array. Pointer I is now sitting just after the last non-zero element. That means everything from index 0 to I minus 1 is already correct. All non-zeros in order. Second loop starts from I. So it only touches the remaining part of the array from I to n. That part is supposed to be filled with zeros. It never overwrites the non-zero section because the condition ensures it starts after the non-zero block. The second loop only touches the leftover part of the array. That's why it does not interfere with the non-zeros you already placing. The two loops are different. The first loop collects non-zeros in order. Second loop clean up the rest with zeros. Because after the loop, I was already at the third index or fourth, right? Yeah. You After the first loop finishes, after the first loop finished, I is already sitting at the next index after the last non-zero element here. So after the first loop ended, it was already sitting at the index just after the non-zero, that was 3 in this case. So the second loop is running for the third and the fourth index here, and initializing its value with 0. Okay. Second loop, it starts at k is equal to I. That means it only touches index 3 and 4. Those are the leftover slots that should become 0 anyway. It never overwrites the non-zero section 0 to I because that part is already filled correctly. So yes, after the first loop, I is at the third index for this example. The second loop safely fills from I to the end of giving here. Modifying third and first index zeros, right? Okay, so when it runs I only modifies the leftover part of the array. Yeah. So let's run our own test cases. First, we will submit it. I think the adding complexity of this will be equal to big of n. We will use the free limit of n. The time complexity of this will be equal to big of n, right? Yes, the time complexity of a final approach is big of n. Here's this is simple. Here's why in simple breakdown. First loop, you scan through the entire array once, moving order forwards. That's big of n. Second loop, k loop, you fill the remaining slot with zero. That's also big of n. In worst case, if all elements are non-zero, there are only a few iterations, but we still count it as big of n. Total big of n plus big of n is equal to big of 2n, but constants don't matter in big of 4, so it simplifies to big of n. You are not using any extra data structures, only pointers, so space complexity is big of 1. So you can confidently say the solution is run in big of n time and big of 1 space. Okay, so now we have solved this problem also. It was a good problem, so I'm adding it in favorites list. Now we have solved two problems. Let's see if it's reflecting in my account or not. Okay, I have solved 8 problems till now. Acceptance is it is now came near to 5%. Okay, let's see what else we have touched. Okay, now what we will do now. We will first let me check the duration of stream. Okay, it is near to 1 hour 46 minutes. So yeah, I think I can. Now we will try the missing number problem again that we solved yesterday without seeing the code. And I will try to explain it also. Okay, first we will remove this whole thing. Now. We will take an integer so equal to 0. What it will do, it will take SOR of this with 0 and another XOR array equals to num. Okay. Okay. Now we will remove it. Int XOR or is equal to 0, comma XOR array is also will be equal to 0. Now we will run a for loop inside this. We started from 0 and we'll go till the last index, that is inside this. What we will do, we will take XOR of all elements with the array. So it is a copy of the original array. Copy of the original array. XOR or XOR equal to I. So it will take XOR of all the elements of 5 and 0, and in the result and in the output what it will give. Let's use xcali draw for calculating that. We will try run that. Okay. So first we will write the stream. Today's A5 C++ DSA surely. Okay. What you're doing? We are doing trial. Next number problems. So operations. What you're doing? We are taking XOR of all elements with 0. So in this case we are taking XOR of 3 with XOR of these elements with 0. 301. Okay, so the array is like let's check. Mm, when to use, I think we have to increase the size. Okay, leave that. So I was 3 commas 0 comma 1. Okay, let's try and make it a little cleaner. Okay, this was the array. We are taking the 0 with all the elements inside that array. That is 3 comma 0 and 1. Okay, so as it takes the element font size. Okay, now it's so let's first make it a little cleaner. So I'll use this pencil. 0, so with all the elements in the given array. Okay, so zeros orbit 3 will be equal to 0. Different values will become 1 and same values will become 0. So it is equal to 3. Then we will take 0 of 3 with 0. So it will what is the result 1 1 and 0. Again it is 3 because 3 is of 0 is 3. So that 1, so 1's body number is 001. See, it's written here. Now 1's offset will be equal to 0. 1's offset 0 is equal to 1. 0's offset 0 is equal to 0. So this is equal to 2. So the for missing number, yeah, this is for finding missing number. After that we will create another for each loop. Set this travels to the whole there and it is taking XOR of the entire array. that we will be returning store of all store with store of array means to store with 0. Why it is 0? Because 0 because now we will try run for this. We have already tried in the loop for finding the missing number, that is 2. So it should give the output 2, but take XOR array. So array is also 2, 0. Just taking XOR of 0 with all the sorry, it is taking XOR of 0 with all the indexes of the array, that is 0, 1 and 2. So the result of it will be, let's draw a line here. We will make it a little bigger. Okay, so we are taking here 0 XOR with all the indexes of the original array. Original array, there were 3 elements in the array, so the indexes will be 0, 1 and 2. So 0 XOR with 0 will give 0 because both the values will be same. So 0 XOR with 1. Or okay, 0, 1. So result 1, 0, 0. It will give the result 1. Mm, 1. That will take XOR of 1 with 2. Is 0. 0 comes 1. 0, 1 will be 1 and 0, 0, 0 because both the values are same. It's coming equal to 3. I have I'm doing a mistake here. So I'll start listing from 0, so it is taking XOR of all the indexes. Oh, 1 minute. Give me 1 minute. P. Hmm. Zorol is private in this right. P. Just what to fix 0 and 3. Okay, number of elements. Zorol is taking Zorol number of elements. Zeros of it 1, 0, 1, 0, 2, 3, 3 of it 3 is equal to 0, 1, 2, and 3. But how? Example 0, 0, number of elements. Okay. It is not giving indexes, it is number of index. Means one number of elements. Okay. It is taking sort of number of elements. Okay. So we take sort of 0 to 1 will be equal to 1 and with this pass 1 the oh no, why it's not working? Its result will be equal to 1 because 0 it is taking sort of 0 with 1. So it will return the original value. After that 1 XOR with 2 will be equal to 3 because these are two different values, so it will become 1 and this will also become 1. These are two same values, it will become 0 and 0 1 1 is equal to 3. Now we will take SOR of 3 with the last element, last number element, that is also 3. So any number, any element n XOR with its with the same number, it gives the result 0. This is how it's working. Number of that's why we have used for each loop, means for each element. And after that, we are taking XOR of all elements with XOR of the result of this with XOR of result of this loop. So to solve it in the output, we will get 2 because 2 XOR 0 will be equal to 2. Let's do it here. 2 XOR 0. So 2 is equal to this. So, I already told you the condition of this before. in the second string that if any number n is taken XOR with 0, it will return the original value C. Same values will be equal to 0. Different values will be equal to 1. So it will again return the value 2. And what we were asked to return here, it was 2. So it will return the true. Only 1 minute. It will first we will run this compilation error. Couple of mistakes. What does it mean? Okay. All. So array, XOR array. XOR is XOR is undeclared, but it is declared now. I less than, okay, yeah, to be less than equal to member of size, so that it will run to the last value, because it is starting from the 0th index and decimal, so it should go to the last index. Comment says copy of the original variable. So this is not copying that, it's XORing the full range. XORing the full range. This is the corrected code. Okay. XOR numbers from 1 to n. From 0 to n. All numbers from 0 to n. We can XOR all elements in the array. Missing numbers, the sort difference here. Missing number is just a sort difference. Okay. Okay. Everything is here. Let's create our own test cases also. Case 4 and case 5. So in case 4 we will write 301 301 comma 5 comma 6, sorry, 4 comma 6, 301 comma 2, 6 we will write 0 comma 3 comma 0 comma 2 comma 3 comma 4 comma 6 comma 8 7. Okay. It will give you the result now. Numbers must consist of values 0 to 5 only. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, number of elements 5. So 0, 1, 2, 4, 5. Yeah. Its time complexity of this will be equal to, if I remember that, I think that I have kind of put this cos big of m. Yes. So finally is equal to time complexity is equal to big of m. Space complexity is also z big of n. No extra data structures. You're only using two integer variables. Yes. So we'll submit it again. Okay. So I'll solve it now and I'll explain this you in the terminal also. So what we done in the today's stream, let's summarize it. First, we solve the remove duplicates from an sorted array problem. Which time complexity was equal to big of n log n. If I'm correct, this was tell time complexity. It is equal to big of n, not log n, because okay. Why not to log big of n log n? Okay, I have done only a linear traversal. In every iteration, there is only one comparison and one symmetry. Total n into 0, n into big of 1 is equal to big of n. Okay. It will be equal to n log n when if we have done sorting. But here array already sorted. Here already sorted array is given. We have to. We are only removing duplicates here. But that's why there is no sorting step. So no log n factor. Okay. So this was the first problem we solved in the today's stream. After that, we done this problem that was moving zeros to the last of the array and moving non-zero values to the front of the array. This we use two for loops. So the time complexity of this was big of n because we are not sorting logic of is also same because we are it becomes big of n log n when then when we done sorting, but we haven't sorted anything here. We haven't done used sorting here. We only used variables and the two for loops, not nested loops also. If it was nested loops, the time complexity it will become it will be to become n big of n cube, but we are traversing. We are using loops, two different loops. That's why the time complexity will be big of n. Because after this loop set, this loop will start. Not like this, like inside if we the loop for loop second loop for loop will be written inside this. So then it will be traversing to the first loop, then second loop, then again first loop and the second loop. But this is we wrote the first loop and second loop outside the first loop. So first loop is running in linear runtime, and after that second for loop is also running in the linear time. After the first for loop has ended. After that we solve the problem that we solved a day before. That was the same problem that we solved in the fourth stream, finding mixing number. We also done the driver of it again in detail. So that's what we have done in the today's stream, day 5 of the C++ DSA journey. So I think I should end this stream. Before testing, I want to, if you think that you learned something from this stream, please do like this. Make sure, please do like the stream and make sure to subscribe to the channel and give me the reviews in the comment section about how I am teaching the concepts or explaining the things, or how or how I am trying to solve the problem. It will help me improve the problem solving and the explanation of topics in the next streams. So do like the stream if you find uh, if you are if you learned something from the stream, and make sure to subscribe to the channel to find my new videos, to find me again here on this channel, solving new problems here on LeetCode and explaining wise more new topics. And that's all for today. I think I will now end the stream now. Okay, it's near to 2 hours and 23 minutes. Okay, so we have solved two problems today, and solved and again revise the problem that we solved yesterday. So in total, this was the summary of the today's stream. Now I am going to end the stream. So till then, keep learning and keep exploring.